Alright guys, so we'll finish chapter 6 and starting chapter 7. Chapter 7 is a really short one, it only has 5 exercises, it'll only take us a few classes to get it done. Uh, with 7a, you've seen like a setup like this before. I think it was in 1G. What I wanted you to do was use your calculator and experiment and see what these different rules look like. And then I wanted you to sketch them and then put down the domain and range. So that's what I wanted you to do last time, but it's actually the same this time. You've just got a few different sorts of graphs. So once you've sketched your graph and put in your domain, range, and asymptotes as well, what I wanted you to do was have a look at these two graphs and these two graphs, and then these two and these two as well, and see if you can see any common themes. So what I would also like you to do is just put down any dot points where you do see any of those themes. So as I said, I want you to grab your CAS out now, sketch all these graphs, and then dot point any common themes that you have. So I'm going to stop this now because I want you guys to do it yourselves. So you should pause it, and then I'm going to have all the answers down here as well. But as I said, this isn't anything new. We've done this sort of thing before in 1G. Alright, so hopefully we've had time to experiment using our CAS, fill in all these boxes, and then check out if there's any common themes. Alright, so let's look at these first couple first. So we've got the form y equals x to the power of -1 on n. So here's a couple of different versions of that. And as we can see, they look like they're hyperbolas, don't they? So I've just written down a couple of the themes that I found here. So they look like hyperbolas. They both have the same domain, which is r except for 0. Same with the range, r except for 0, because of those asymptotes. Okay, so there's a vertical asymptote and a horizontal asymptote as well. All of these things are the case unless, of course, it's translated up or down or left or right as well. Now let's have a look at this rule here. So this is the rule of your most basic hyperbola. The reason I put that there is because these look like hyperbolas as well. Let's look at the form though. So our form is y equals x to the power of -1 on n. I can change my hyperbola form to look like that. So a hyperbola is actually within this sort of group of functions. That's why they look the same. So let's move down to the next couple here. So now we're looking at y equals x to the power of -1 on n when n is an even positive number. I should have said up here before that's an odd positive number. So we can see that we've got 3 there and 5 there. So down here we've got 2 and 4. So even positives, odd positives. And we can see these two look quite similar as well, don't they? Again, they have the same domain and range, and asymptotes as well. But what we can see, or what I could see, is that they sort of only show one side of a hyperbola, don't they? So they show this bit, a hyperbola would have that bit as well. So they show that bit, hyperbola would have that bit too. What I want to do though is have a look at the rule over here. So this rule here, I've just changed it so it doesn't have a negative index, so I've moved the square root down to the bottom. I want to look at these x values here. So these are our negative x values, and it seems like we've got no line there. I just want to kind of point out why that's the case. If we put a negative x value into our rule, you can't have a negative under that square root, can you? So that's why there's nothing there. The answer would be undefined there, meaning that there's no line. Okay, so that's the same over here. If we put this rule, if we wrote this rule down, I'll quickly do it. As a root, it would look like this. Again, if you have an even root, so there you've got 4, over here you'd have a 2. You can't have a negative inside here, otherwise it's going to be undefined. So that's why there's nothing in this section as well. Alright, so this middle bit here, that's something that we've gone over before. I'm not going to spend much time talking about that. Let's move over to the next ones. Alright, so the form that we're looking at now is y equals x p on q, where q is an odd number, so the denominator is an odd number. Alright, now these two look a little bit different, but it's actually not because of the bottom number, so it's not because of the 3 and the 5, it's actually because of the 2 at the top. Now if I change, or if I move this rule into this form, we can see that underneath this cube root we've got an x squared, right? Now I want to bring your attention to what's actually happening in this graph here. With these negative x values, let's think about a negative x value. If we put a negative x value in here, it's always going to become positive, isn't it? Because we've got a squared there. So that's why this one doesn't have a section that goes down the bottom like this one does. Okay, so with this one here, if you put a negative number inside there, you could get a negative number back, couldn't you? Okay, so that's why we have negative y values down here, negative answers. Okay, but if we have a rule where you've got your odd up the top, your odd down the bottom, it's going to have that sort of shape. But if you've got an even up the top, you're not going to end up getting any negative answers, so it will end up bouncing off that x-axis like that. Alright, let's move on to the next couple. Alright, so I've got my CAS. I've put these two rules in, and I've found out that they have the same domain and range, and that they look like square root graphs, which makes sort of sense, doesn't it? Because they pretty much are. So square root is pretty similar to that 4 root. Square root is pretty similar to that 6 root, isn't it? So it does have that same shape. Now, similar to what happened up here with these ones, how we couldn't get answers for negative x values, we can't get answers for negative x values over here as well. Because if we have a negative number underneath here, it's not going to work. It's going to be undefined. Exact same thing for over here as well. Alright, so hopefully we're all good for 7A. If you are struggling with any of that, make sure you're asking questions. I'm going to move over to that one exam question now. Alright, so let me explain what this question is actually asking before we try to do it. So this bit is the most important. We've got some rule called f, but we don't actually know what the rule is. Now this part's saying that we have this function called f, and it's had this certain transformation, and we've got this function called f, again the same thing, and it's had this transformation, and if we take them, or take this one from that one, it should end up equaling 0. We just need to find out what that rule is, or what that function is. So it could be any of these ones here. Before I start explaining anything, this one here, you see this bit with the vertical lines, so that's showing like absolute or modulus. That's not in your course at the moment. This is an old question. As you can see, it's from 2013. So this stuff here, you don't need to worry about that for now. Actually, there's one part where we use it really quickly, but it's not anything too serious. So don't worry right now. Okay, now with this question, I honestly can't think of another way to do it apart from trial and error. There might be, and if there is, as I said, I don't know it right now. There's nothing wrong with using a bit of trial and error in these multiple choice questions. It will take you a little bit longer, so it's probably not ideal, but it will work. Alright, so I'm just gonna see if this works for this rule, then this rule, then this rule, then this rule, then this rule. Hopefully it's one of the earlier ones, so I don't have to do more working out. But as I said, I'm not sure how to do it faster. You could use your CAS by defining as well, but for now I'm just going to use, or do it by hand, sorry. So let's use this rule here. Alright, so that's what we're using, and we need to do this sort of thing to it. So instead of x, we've got 2x. minus 2 times the whole function. So that'll become that. So that gives us, so that'll become 4x squared, so that will become 2x squared minus x squared, which equals x squared. Now, that's not 0. They told us that it has to equal 0. So that does not equal 0, so that means it can't be this one. A is no good. Let's move on to B. So for B, the rule is this. Okay, let's do the same thing. So instead of x, we're putting in 2x. Alright, so that gives us that. And then this bit here would be 2 times, you could say root 2 times root x. These definitely aren't the same thing. That's not going to end up being 0, so it's not B either. So let's move on to C. Okay, so as you can see, it's going to take long if it's this one. I really hope it's not this one. Alright, so instead of x, we're putting in 2x. As we can already see, they're the same thing. So if you take something, or take the same thing from something, it's going to end up equaling 0. Therefore, our answer has to be C. Done.